Today, I'm going to show you how to solve the LEETCODE question 148 sort a list, and this is a median question. It's giving the head of a linked list, return the list after sorting it in ascending order. It's kind of similar to yesterday's question. The difference is this time it's a linked list, but I'm going to use the same merge the sort algorithm to solve this issue. Linked list is slightly different from the array. So there are a few things are super important to remember. If you look at the list example here, that they give you number 4 2 1 3. After it's sorted, it become 1 2 3 4, and it's actually the same thing. So the goal is for us to find a midpoint of this linked list and divide the linked list into the left half and the right half. And I'm gonna show you how to divide a linked list into half. The last step will be merge them together, and then the method to merge them together is super similar to an array. And this is the second example that they give to us here, -1 5 3 4 0, and after sorting it become output like this. And in the last example, if head is none and you want to return a none. So this is a question got asked by Facebook, Amazon, ByteDance, Uber in the last 6 months. So when we code up this question, we want to rule up a few exceptional cases, and after that we want to use a way to divide this linked list divide this linked list into half. Essentially what you wanted to do is you will have 4 1 3, and then you basically want to divide them in half, and you want to call the sort list function on the left side of the linked list, and then call this function on the right side of the list, and then the last step will be merge them together. And I'll show you how to do this in code. When you start coding, you want to rule out a few edge cases, like they mentioned to you in the example that if head is none, you want to return none. So we will say rule out the head none case, or not head.next, because if you don't have the second value, if you only have the first value, then you simply don't need to sort. You don't need to sort at all. So in this case, we want to return head. Basically, in either case, when you return head, you already rule out the either cases. So then we want to split this list, but which I'm gonna do in a little bit. But after, let's say we have the left array, then we want to call the left function, the sort list function on the left array, and then we want to call the sort list function on the right side of the array, right? And then when we try to split the list, what we wanted to do is, so the left array, its head is head, right? So the right array, how do I cut a linked list into half? And the second half of the beginning will be the head of the right half of the list, right? So in this example, 4 2 1 3, and the 1 will be the new head, right? So let's say self dot I'm gonna call a function to try to get mid, and I'm gonna write this function in a little bit. Let's say I get the midpoint in as this 2, right? So let's say right, so 2 is the right that we get in this point. 2 is not actually the beginning of the second list when you have an even linked list. So what I wanted to do here is I want to give a temp value to the right.next before I break the linked list here between 2 and 1. So I remember the value, and I want to set right dot I want to set right dot next to none here. So I want to set to's next as no. So in that case, I break the first half of the linked list. And then after that, I want to set the beginning, the head of the right list to temp, which is the value right dot next that I saved originally. After these steps, I already got the second half of the head, which is the right. After I saw the left list and the right list, what I really wanted to return the value is merge them together. So basically for the merge function, I'll write it in a little bit and I will put it as left and the right. So that way, this will be the result that we are looking for. So here I'm gonna write the first function, get mid. So I'll put a self and pass the value as head. So in the linked list, it's very easy to find the midpoint of a linked list. How you do it is you have a slow pointer and you also have a fast pointer. And the slow pointer, when slow pointer move 1, faster point move 2. So when the fast pointer is at the end of the list, the slow pointer is always at the middle of the linked list. So let's say you put slow as head and fast as head dot next. So then you want to start move the slow and the faster point. While fast and fast dot next exist does not equal to 0, I wanted to move the slow point to slow dot next and fast to fast dot next. That means the faster will move 2 and the slow will move 1. While the fast and the fast dot next equals no, I want to return the slow, which is the midpoint. So we already found the midpoint and here. And then this is the function. And the next function that I need to write is the merge function. So here I'm going to define this merge function here. And I put left and right. So let me put it here and pass the function. The merge function here is super similar to the linked list merge function. In linked list, to make the code more easier, we always write a dummy pointer, and I'll give a list node, and I'll set the current pointer to dummy while I start going through the list. So while left and right exist, right? So I'm gonna compare the value. If left dot val is smaller than the right dot val, so my current dot next has to be equal to the small value, which is the left. And after I have the value, I'm gonna move the left pointer to left dot next. Else, in this case, if the left value is bigger or equal than the right value, so then the current dot next value, I want to set it to right. So after that, I want to move the right pointer to right dot next. In either case, the if and else case, I gonna move the current point to current dot next, shift it to the right side. And in this case, if they're still left, then I will set the current dot left to the rest of the left list. And if right still exists, I'm gonna set the current dot next to the right side of the list. And after for this function, when you merge the left and the right linked list together, what you wanted to do is return dummy.next. It's basically the head. And then you basically That's all for the code, and after you divide them, you get a middle, divide, and then you merge them together. You call the function on the left sorted array recursively, the right side array, and then essentially what you return is merge the left and right. And then you can see the code runs as expected. Let's submit the code. Yep, it went through. If you think this is helpful, please like the video and subscribe to my channel, and I'll have more LeetCode questions coming up for you. And I'll see you soon. Bye bye.